The sun can shine and give off heat non-stop all year round because nuclear fusion reactions are constantly happening inside it. However, its nuclear fuel will eventually run out one day. We know that when a massive star reaches the very end of its life, it will undergo an incredibly violent explosion, which is what we call a supernova. The electromagnetic radiation produced during this process can even light up an entire galaxy. It also releases gamma rays, X-rays, and high-energy particles, causing devastating damage to life on surrounding planets. As early as 1054 AD, the ancient Chinese astronomer Yang Wei witnessed a violent supernova event. He observed a dazzling bright star suddenly appearing in the sky. And because it was so incredibly bright, it could even be seen during the day. At the time, it was called the guest star, and it was meticulously recorded. Through modern telescope observations, it turns out to be what we now know as the Crab Nebula. Calculations show that usually only stars with a mass greater than 8 to 10 times that of the Sun will undergo a supernova explosion. When a massive star's nuclear fuel is about to run out, it will first enter the red supergiant phase, rapidly expanding in size. This is essentially a warning that the star is about to die. After this phase ends, the entire star will suffer an extremely violent explosion because its balance is broken. The energy released is equivalent to the total energy our Sun will release in its entire main sequence lifetime. At the same time, it ejects a large amount of material outward, including the heavy elements created inside it, and its core will collapse into a neutron star or a small black hole. If such a supernova occurs within the Milky Way, in most cases it would still be visible to our naked eye. You would suddenly see a new flickering light in the sky that lasts for days to months. And the material ejected by these supernovae can eventually flow into interstellar space and, driven by gravity, form the next generation of brand new stars. For example, our Sun is a second generation or later star. But for small-mass yellow dwarf stars like our Sun, their ultimate fate 5 billion years from now is not a supernova explosion, but rather the formation of a typical planetary nebula. However, Earth's position is relatively safe. Even the red supergiant Betelgeuse, which is nearing the end of its life and could explode within the next 100,000 years, is still far away, about 640 light-years distant. It's simply not close enough to pose a substantial threat to Earth. So, in the long term, Earth doesn't need to worry about being affected by external stars. And we don't need to be so afraid of supernova. Because, in fact, at the very beginning of the universe, shortly after the Big Bang, the universe contained almost only hydrogen and helium. It was precisely because of gravity that the first stars gradually formed. These first-generation stars were almost all cosmic giants, which meant they had shorter lifespans and more frequent supernova explosions. This enriched the universe with all sorts of elements. For example, the chemical elements that make up your body, like carbon, nitrogen, oxygen, and iron, which are essential for life, all originated from nuclear fusion inside stars. Therefore, we can say that if not for billions of stars constantly being born and dying, renewing themselves, there would be no diverse universe as we know it today, and certainly no life forms like us humans. So, ultimately, we are also a part of the countless stars.